All right, you guys. Today we're going to talk about functions. This is section 2.1 in your book. And today we're going to talk about putting the fun in functions. You guys, before we talk about functions and what they are and what defines them, we need to talk about relations. A relation. Really, there's so many different things that are relations in mathematics. So a mathematical relationship, it is a mathematical relationship between any set of ordered pairs. Remember, an ordered pair is both an x and a y, so x comma y, and can be expressed as a mapping and a graph. Now, I'm sure that you guys have seen graphs before, but what I don't know is if you guys have seen mappings before. I would imagine a lot of people haven't seen mappings yet. So I'm going to show you guys examples of ordered pairs, mappings, and graphs. Ordered pairs are usually just a set of coordinates with the parentheses around them. So you can have 1, 2, 5, 9, -10, 0, things like that. This is a set of ordered pairs. We usually put these curly brackets around the outside to denote a set of ordered pairs. So this is a relation. Now, mapping is the one that you guys probably haven't seen before. And the way we show mappings is you draw two ellipses. One to the left and one to the right. God, those aren't great. Oh, well. Where this is the x and these are the y's. So if I was just to make up a mapping, I could say 1, 2, 3, 10, 25, 39. And then to show that 1 goes to 10, you put an arrow from 1 to 10, and 2 goes to 25, and 3 goes to 39. They don't always necessarily line up like the arrows can go up or down or different ways, but it's essentially just telling you what the ordered pairs are, that there's a 1, 10, a 2, 25, and a 3, 39. A graph. For example, let's do a lazy parabola. I'm just picking a graph at random. So a lazy parabola looks like this. This is a relation because each of these little parts of it represent ordered pairs. So it's really just like a bunch of ordered pairs put on a graph and connected with a curve. Points, ordered pairs on a graph don't necessarily have to be connected. You can have points floating in space on a graph that are a relation, but a lot of times when we're dealing with relations and functions, they are sort of connected. Next, we're going to talk about functions. So you guys, every function is a relation, but not every relation is a function. What defines a function, and I'll go into what I mean by that in just a second, is a function is a special type of relation. So remember, every function is a relation where each input has exactly one output. Now, what that doesn't say is that each output has exactly one input. That doesn't necessarily have to be true of functions. The way I kind of remember this is that it's okay for many inputs to go to one output. So this is inputs. Can go to one output. But it's not okay for one input to go to many outputs. I'm using input and output here. You could easily say X and Y's. Yeah, it's the same thing. So just a reminder about what functions do. You need to think of functions like machines. Machines where you can feed a number into the machine and then a number comes out of the machine. So if I pick a function at random like 3x plus 4, this takes each input, triples it, and then adds 4 and then produces an output. So if I was to put a 3 into this and I drop it into the machine, then there's going to be a 3 right here. So you get 3 times 3, which is 9, plus 4, which is 13. So then a 13 would come out of it. I heard somebody say one time that all poodles are dogs, but not all dogs are poodles. It's the same situation with functions and relation. Every relation, nope, backwards jolly. Every function is a relation. But not every relation is a function. So remember, each input has to go to exactly one output with functions. So let's talk about whether or not each of these is a... So they're all relations. Everything we're going to do today is relations, but some of them are also functions and some of them are not functions. So we're going to look at each one of these representations and decide whether it's a function and then say why or why not. The first thing I notice with number 1 is we have ordered pairs, 6, 12, 8, 16, 10, 16, 12, 24. Now, the one thing that my brain zooms in on is this right here, that there's 2 16s in here. So we have 2 inputs that go to the same output. That is actually okay. It's almost like the kind of trick question. The flip of that is not okay, which we'll see in a second. So this is a function. And the explanation is that it's okay for many to go to 1. Now, the next problem, when I look at it, I see that this input of 5 goes to 20, but then that input of 5 also goes to 125. If I go back to the definition of a function, it says that each input has to have its own output. This input of 5 has double outputs. It's got an output of 20 and an output of 25. So this is an example of 1 going to many. So this is not a function. I guess instead of saying 1 goes to many, I could say 1 can't go to many. So, not a function. Next up, we have some mappings. Now, this number 3 right here, a lot of people look at this and they go, oh, that's definitely not a function. But remember that just because it looks so weird, they're like, everything goes to 2, functions can't do that. But it's actually, remember that many can go to 1, but 1 can't go to many. It's just that each input has to have its own output. So it's okay to have 1 go to 2, and 2 go to 2, and 3 go to 2, and 4 go to 2. That's fine. It's a function. So the explanation is that many inputs can go to 1 output. It's totally fine. Now, number 4 looks like almost like a function. It's pretty close to being a function, but there's a problem. And the problem is this, that 1 goes to 8 and 1 also goes to 2. So this is 1 going to many, which is not okay. Even though 2 maps to 4 and 3 maps to 6, which that's chill and awesome in function world, but the 1 going to 2 and the 1 going to 8 is a problem. So this is not a function. It's still a relation, because a relation is just any relationship between inputs and outputs, but it's not a function. Now, if you were to look at a graph of y equals negative 3x plus 7, that means it would have a y-intercept of positive 7, and then it would go down 3 over 1, down 3 over 1, down 3 over 1, and then you would connect the lines. And then we'll pretend that actually goes through all those points. We'll just make the dots a little bit bigger. Yes, this is a function because each input is going to have its own output. There's no way for one input to go to two different outputs. So yes, this is a function. So one way to say that is that each input has its own unique output. Now, you might not remember with number 6 what a square root function looks like. I call this guy the space dolphin. Here's what I mean by that. It starts at sea level right here, and then it's a dolphin jumping out of the water and then sailing up forever into space. So it looks like this. This is also a function because, once again, each input is going to have its own unique output. There's no way for one input to go to two different outputs. So yes, it is a function. For the same reason as number 5. Now, there's something when you're looking at the graphs of relations to tell that if they're functions by using a vertical line test. So the vertical line test. The way you do a vertical line test is you hold your pencil vertically and you sort of trace every part of the function, and then you see if it touches your pencil once or if it touches your pencil more than once. So for instance, with this first problem here, if I do a vertical line test, there's only one spot where it touches the function. No matter where I put my vertical line, it will only touch once. So yes, that is a function. Passes a vertical line test. Same thing with this parabola on number 2. No matter where I put a vertical line, it's going to only touch once. I can move my vertical pencil anywhere around, and it only touches the graph in one spot. Now, something like number 3 immediately fails a vertical line test because if you put a vertical line right through the middle of it, it touches twice. Oh, sorry, I forgot on this one to say yes, it's a function. Now, number 3, this is a problem because it touches here and here, so this fails a vertical line test. Not a function. And we'll say the reason is it fails vertical line tests. The other way to think of that is that it fails the definition of a function because one input would go to multiple outputs. Here's what I mean by that. I'll do it in green. This input, whatever it is, 5 or 3 or I don't know what the scale is, so whatever, that would go, like, let's say this was 5 right here. That means that this is 5, and I'll just make these numbers up, 512, and then this is something like 5 negative 12, which means one input goes to two different outputs, and that's not okay. All right, you guys, that's all I have for today. Your homework is embedded in the assignment here right below this video. Please ask questions during class if you have any problems. And also remember that the worked out solutions are in the file section of your Canvas. Good luck.